To be solving for the lengths of sides or diagonals and solving for the measure of the angles in a parallelogram. So the first example, find YZ. So YZ is this length here. And we know that it is congruent to the opposite side. So if they're congruent, we're going to set them up in an equation where they equal each other. And then solve. So x equals 4. And now to solve for the length of yz, I'm going to plug it back into the expression for yz and substitute 4 for x. So the length of yz is 45. So remember, don't just solve for x, answer the question. If it says find yz, you're going to have to substitute it back in. Okay. Here's our parallelogram with diagonals. It says that NS is 2x plus 7. And SQ is 5x minus 23. It wants us to find the full length of this. Diagonals in a parallelogram bisect each other, so that means that they are equal on either side, or where they split in half, it's splitting them perfectly in half. So they are equal to each other. So let me put my little markers here that these are congruent and set up the equation. So now that I know that x equals 10, I'll pick one of the expressions. I'll use the 2x plus 7, substitute in 10, and that will be 27. Now remember, 27 is only the length of half of NQ. So I'm going to have to multiply that by 2 to get the full length of NQ. So NQ equals 54. Now let's work on angles. So we're given the measure of two angles. It wants us to find the measure of angle R. So this is what we're trying to find. One of the properties of a parallelogram is that angles on the same side equal 180. So we know that angle P plus angle Q equals 180. So we set up the equation for that. 3x plus 5 plus 8x minus 12 equals 180. X equals 17. So we have expressions for angle P and angle Q. Which one is going to help us solve for angle R? P, because it's the opposite angle. We know that this is congruent to this. So let's substitute 17 in for 3x plus 5. $56. So we'll say there, our answer is the measure of angle R is 56 degrees. So remember, you're putting the degrees symbol anytime you're giving the measure of an angle, but don't put the degrees symbol if you're giving me the length of a segment. Okay, last example for today. If the measure of angle ABC is 115 degrees, find the measure of angle ADB. So it's giving us the measure of angle ABC is 115. So I'm going to mark a little orange mark here that tells me that entire part. Let me zoom in here. That entire part is 115. It's asking us to find ABD. Sorry, ADB, which is this. ADB. Remember, you're always looking for the middle letter. That's your vertex. And then the lines that extend to the other two letters. So when we have diagonals here, I think it's important to remember that parallelograms have parallel sides. So when you go back to a couple of objectives ago when we talked about transversals and parallel lines, we had all those angle relationships. So we have alternate interior angles. So I'm going to start to fill some of those in. These are alternate interior angles. So that means I can write 4x plus 6 here. And I can also write 6x plus 11 here. Because they're alternate interior angles. So I need to set up an equation that allows me to solve for x. And I'm given that the measure of angle ABC is 115. So I can say that 4x plus 6 plus 6x plus 11, sorry, that should be minus 11, minus, equals 115. I'm going to put the little note up here. Alternate interior angles are congruent. Alternate interior angles are congruent. So let's solve. x equals 12. Now I need to find the measure of angle ADB. Well, that was this one here, ADB. So substitute it back into that expression. (61°). So my answer is the measure of angle ADB is 61°.